Good afternoon. Hello. Hello. Các bạn ơi, hôm trước các bạn học tới đâu rồi ta? Bắt mình học programming giải bài tập chưa ta? Hello Phương, Yên Phương. Hello Yên Phương. Phương cho cô biết hôm trước lớp mình học tới đâu rồi Phương?
Dạ, cô gọi em mà cô.
Đúng rồi. Câu hỏi em là
Dạ.
bữa mình học tới đâu rồi?
Dạ, hôm trước mình học, mình coi qua cái ví dụ đầu tiên trong cái assignment Go Programming của cô á.
À.
Dạ, mới bài 1 á cô.
Example đó đúng không em? Hay
Dạ, cái
assignment chứ?
phần vụt mà cô gửi.
Assignment các bạn có về nhà làm assignment chưa các bạn? Làm assignment đó đọc cho cô nha. Các bạn lớp các bạn học cái gì ta, syntax, modify syntax chưa ta, giải bằng syntax method chưa? Chưa đúng không? Vậy hôm nay cô sẽ dạy phần syntax method. Cô chưa dạy syntax method đúng không các bạn?
Dạ chưa ạ. Bữa cô mới dạy tụi em tới preemptive Go programming thôi.
Vậy bây giờ cô bắt đầu dạy nên preemptive ha. Rồi bây giờ cô sẽ dạy modify syntax. Everyone, for Go programming, we know how to use the graphical methods, right? For Go, we have graphical methods to solve for two variables. But more than two, we must use modify syntax methods. Modify syntax method. That is used for two variables. So for that methods, I will send you file. So, new file. Everyone, I send you the modify syntax methods file in chat box. So today we study with modify syntax methods. But before we study, let me review for you what is the syntax method. Okay. So but let me open the file. Các bạn nhìn thấy file cô chưa? Can you see my file, everyone?
Dạ có cô.
Okay. So, everyone, let me review what are the simplex methods. Still remember simplex methods, everyone? Okay. Simplex methods is like, first of all, we should define initial solution. So simplex methods, that is the algorithm to find a solution, right? So we should define this. And after that, we improve them. Find the initial solution and improve initial solution. So, and after that, we find the optimal solution, right? So, for initial solution here, we define basic, variable, and non-basic, group basic, and non-basic variable. Everyone, do you remember what is the basic, what is the non-basic? So look at example here, everyone. We minimize, right? And you have the subject 2. So right now we find the optimal solution. We find the optimal solution for this case. So everyone, in here, we have totally 10 variable, right? 10 variable. And we have 4 contrasts. 1, 2, 3, 4 contrasts. With 10 variable, 4 contrasts, so we let 6 variable. So we will let 6 variable. Let 6 variable equal to 0. So the variable we less equal to 0 here, we call that a non-basic variable. So you substitute 6 variable here equal to 0 in the model, so you can find the solution. By solution here, we call that the basic. So for example, here I select D1 minus equal to 0. No, sorry, x1. I select x1 equal to 0, x2 equal to 0, d1 plus equal to 0, d4 plus equal to 0, and so d2, d3 plus equal to 0, right? d3, d2. So because this equal to 0, so in this case, so they just consider 8, because if you put 10 or put A here is the same. So here I put 10. So we select 6 variable here equal to 0. So what we can get? We get here x1 and x2 equal 0, right? D1 minus will be equal to 80. And D2 minus equal to 70. D3 minus equal to 45. and D4 minus equal to 10. So all of the variable here, you find that at a U5 should be equal to 0, greater than equal to 0. So we call that the initial solution. Everyone, any question in this? Any question in here, everyone? You remember? So why we select 6 variable here? Can I select other variable? My question. Hello, everyone. If I select different variable here, is this okay or not? Manuing, hello Manuing. Manuing is my TA Operation Research 1. Hello. So my question is, can I select other variable here? You remember?
I think you can. Oh wait, I'm not sure.
At the Operation Research 1, okay. Everyone who lets me know that can we select other variable in here? Can I cannot?
But if you choose the variable to be non-basic variable, so they cannot have a value, right?
You mean not value in basic?
Yeah.
No. So everyone, any other idea? Bùi Nguyễn Quang Minh. Hello Minh. You remember?
Not quite sure.
Okay, all right, everyone. In here, actually, you can select different value here, different variable here, equal to 0. You can select 6 to 10, 6 of 10 variable here, equal to 0. But make sure that the values you guess here must be greater than 0. Make sure that. So you can. But in here, why I select this value equal to 0? Because I want like this, everyone. So for example, we have the feasible region like this. So it means for simplex method, it means we will check the corner point, right? We check the corner point. The solution will be the corner point here that is one of the candidates for optimal solution. So if you select, I select x1 equal to 0, x2 equal to 0, because I want to start from here. As I want to start from here and I go to this way or I go to this way. To check that. So if you select different here, different variable here, you may start from here. Okay, you may start from here, you go to this way, you go to next, you go to next, or you can start from here. So you can, right? Everyone got that? Okay. So everyone, I start from here. But initial solution here is cannot be the feasible optimal solution, right? So I must to improve them. The second step is improve. Improve is mean I check another one. I see that is optimal solution or not, right? So, but how can I improve them? I improve them by you remember entering variable and here leaving variable. So I improve the initial solution by select the entering and leaving variable. So that the process will be repeat until I find the optimal solution. That is the simplest method. So for entering, it means I select the value from the non-basic variable group here, enter to the basic, and from basic, leaving here, leaving out of the basic variable, so into non-basic. So I'm repeat that until I'm find out the most solution. It means when I entering, so and leaving, it means I move to another point. Okay. Everyone remember that one? So for Go programming, everyone, for Go programming. So here I'm put a variable. So actually you can put 10, but because in here D2 plus and D3 is equal to 0, so cannot improve, so I don't want to put it here. But if you just do it normally, you can put D2 plus and D3 plus in here. Okay, so I'm put all the variable in the second row. And what I feel now in the first row? The first row here, look at the first row. Look at the model here. So x1 here, the coefficient is 0. Look at the coefficient of objective. So x2, no coefficient. D1 minus is coefficient P1. And D2, that is coefficient 5 P3. And 3 P3, 0 for P4, P2. Okay. And so in here, the second column, the basic variable. So I have 1, 2, 3, 4 basic variable and put it in here. And I put the coefficient of the 4 variable here. So for example, P1 for D1, 5 P3 for D2 minus here. And yeah, I feel that all the coefficient here. that is my finish. And so how can we fill the number in this table? So for the second one, x1, we have the coefficient of x1. So this area we fill for subject 2. Subject is coefficient 1, 1, d1 minus is 1, and the rest will be equal to 0. And d1 plus is equal minus 1 here. So you have four criteria here, everyone. 4 criteria. So we put it in four constraints. Sorry, 4 constraints. You put 4 coefficient of 4 constraints, and that one is the right hand side. Okay. Any question for me? See any question? Okay, you have no questions, so let me continue. Next is everyone. Or the next table here. Not next table, the same table, but the second part. We have 4 priority. So we put 4 priority here. 1, 2, 3, 4. So Cj minus Zj minus Cj. So that it look like Z when you study in simplex methods and operation research, but Cj minus Z minus C is it's the same. So everyone, we put 1, 2, 3, 4 here. So right now, how we can fill the table here? If we want to calculate filling all the table here, we must to calculate Zj minus Cj. So we start with the column 1 here. What is the Cj minus Zj? So here that is, you take the basic here, you time with the coefficient of x1, and you minus 4 coefficient of z here. So we can find the Cj. So for example, I have 1 C1 minus Z1. So what is the J1? J1 is mean I have P1 times 1 plus with 5B3 times 1. And here that is 0, right? Minus 0. So I have here is P1 plus 5P3. So the general formula here that is we take the element in the CP column times with the corresponding with element in XJ column minus CJ. Everyone, X here that is the multiplication. Is multiplication. And here. So you can do the first column, second, the third until 8, and CP also. So CP is means you take P1 times with 60, 80 and 5, P3 times with 70, 3P3 times with 45, and 0 times with 10. Okay. And that you guess the number in here. Get the number in here. So it means we fill in all the table. So we have the first table. So right now we continue with the entering. We improve, right? Improve the initial solution here. Improve the initial. So improve the initial solution. So we start with find the largest positive for entering here because that is the minimize problem, right? So we select the largest positive number, coefficient. In P1 is first, P2, P3, and P4. So if you look at this, everyone, P1, that is first priority. So we choose P1 first. P1, you choose the last positive is one here and one here, right? So you can choose one of them. Choose X1. Okay, X1 or X2 the same. Choose X1. So X1 will be entering. So X1 here, everyone, X1 here will be entering. X1 will be entering the basic. So which one will be leaving? So the leaving is we choose the smallest ratio. So what is the smallest ratio? So here that is the pivot column, right? That is pivot column, everyone. Pivot column. So you take a right hand side. You divide for pivot column. So 80 divide 1, 70 divide 1. So 45 divide 0, 10 divide 0. So that is undefined. So we compare the 80 and 70. 80 and 70. So which one that is smallest, everyone? Divide 1, right? So it means D2 minus is leaving. Is this? So here D2 will be entering here. So I write D2 minus 2 minus equal to 0 and X1 here. So X1 will be entering the basic. Okay. Any question, everyone? This one is clear. So, okay, the intersection, the pivot column and the pivot row here, that's value. The value here already equal 1. If this one equal 2, so you must to divide 2 for all here, right? For all the rows. Right? Make sure that the value in here must be equal 1. So, but this one is equal 1 already, so we don't need to consider anything. This is number 1. Okay. What different the pivot column and different with the rest, teacher? The pivot column is mean x1, that is the entering variable, right? So the column of x1 we call that is the pivot column because x1 is entering. Another is not entering variable. Okay, Fu? Okay. Pivot row, it is the same idea because the D2 minus here is leaving. So the column, the row include D2 minus here should be the pivot row. So that's one already equal 1. And everyone, for the entering variable here, it must be, the rest should be equal to 0. So this one should be 0, 0, 0, 0, 0, 0. Because that is the basic. So everyone, look at the basic variable. For example, D1 minus, right? D1 minus here. You can see intersection with the column and the row, that is number 1, right? And the rest here equal to 0. So right now, x1 be the basic variable. X1 become to basic variable. So x1 must be follow the rule. It means the intersection here, if x1 here equal 1. X1, so for example here, so x1 entering the basic. So x1 here must be equal 1 and the rest must be equal to 0. So right now, how we can everyone, so how can we transform the number in this row become 0, everyone? So in here, you look at this. This one, not 0, right? Here, not 0. That one is not 0. It's not 0. So we should, right, operate like the matrix. It means here is for 1. So you must to multiply with minus 5 all the row. You plus with this row. So the number here should be equal to 0, right? Also the same. We try to make it equal to 0. So we will have, here you see 1 and 0 because that is basic. And we have new value here. Everyone, is it okay? Any question? No question, right? So we just do the first round, that is the entering and leaving. But you look at this one, you can see here we have any largest positive coefficient, any positive coefficient? No, right? No positive coefficient. So for the P2, no positive coefficient. But for P3, you can see here we have number 3, that is the positive coefficient, also the largest one. So we do the same way. Entering. Right now, D1 minus is entering. So D1 minus is entering the basic. So here is D1 minus. So for D2 take this. We divide for this column. Which one is the smallest? 10. We just consider small ratio greater than 0, everyone. So D4 minus should be leaving. So here D4 minus leaving will be in here D4 to 0. So we do the same, everyone. Divide for 1. Here 1 already. Right now we try to make the rest number here equal to 0. So you can see 1 here and the rest equal to 0. And we check the P3. We check the P3 here, still have positive number. So we have the positive number, the positive, but here we also have the positives. So if in this row we have negative, so we continue. But in the priority, the next priority, we have negative, positive, so we stop here. We stop here. So it means that we achieve P1 and P2. It means for the row first priority and second priority we can achieve, but for the third and the fourth we do not achieve. And the solution, you guess that the x2 will be equal to 20, x1 equals 70. D3 minus 25 and D1 plus is 10. Okay, So you take the number here, you substitute in dash one. That is go program and that is go constraint, right? So you will get the value. If that is the profit, so that the profit still get. That is hour, maybe the hour. So maybe that is the overtime is, yeah, you just substitute here. You get the goal. Any question, everyone? I'm waiting for your question. Can you explain how to set up the cell for row 4? Okay, so I already explained here. That's one related with zj minus cj, right? Zj minus cj. So here, z1, look at the board. Z1 minus c1. Z1 minus c1. So we take here cb time with the coefficient here. You can see b1 times 1 plus with 5b3 times 1. So here is equal to 0, right? 0 times with 0 equals 0. And minus 0. So here is p1 and 5b3. So here you can see p1, I put the coefficient in 1. p3 is coefficient in 5. And the rest is 0 and 0 here. Got that, Phương? You got that, Phương?
Can you explain the second column too?
The second, yeah, you take this one.
I mean the lower four. The lower four, cj minus zj minus cj.
I cannot get your point. Sorry, because it may be the internet. I cannot hear you clearly.
Can you explain the column with 0, 3, 0, 1?
Column 0, 3, 0, 1 here.
Yes.
Okay, so it's Z2 minus C2. So you take here P1 times with here 1. 5B3 is 0. 3B3 times 1. Right? So you have P1 plus with 3P3. Right? And you minus 0 here. So 1 in P1 and 3P3 here. Okay. Clear through.
Thank you. Let me check it again.
Okay. So you can do one by one like this. You take the CB, you time with the column here. Can you explain the column D4 plus and D1 plus? D4. It means explain in CJ minus GJ minus CJ. Vin?
Yes.
Okay. So here you take, that is you have minus. So you have minus P1, right? Minus P4. So here minus P1 and minus P4. Okay. Here we minus P4, right? So this one here just only minus P2. You take this, you time with this one, and you minus with P2. Okay, Uyên?
Dạ được rồi cô, nhưng mà tại vì em thấy ở dưới á, nó chỉ để là B1, B4 nên em mới không biết cô. Lúc mà cô trình bày ở dưới á.
Ở dưới nữa hả?
Cái cô giải thích á.
Nhưng mà giờ em rõ hơn không?
Dạ rõ rồi, tại em tưởng là nó tại sao nó nhân nhau mà là chiều 1 với chiều 1. Em nghĩ là em tưởng giống nhân.
À, mấy cái này hả?
Dạ ở dưới nữa cô, cái của hình như Z7 với C7.
Tại vì mấy cái này á, khi mà vô đây nó bị typo á, cái có thể cái word này nó bị cái word này nó cũ quá rồi đó, cái nó vô đây.
Dạ không cô, cái đó em hiểu, nhưng mà cô coi của Z7 với C7 thử đó cô. Đó nó để gì đó cô, nên em nghĩ em tưởng là em không. Kết quả nó ra là B1, B4 thôi.
Tại vì qua cái word đó, copy ra nó bị nhầm. Nhưng mà nguyên tắc là vậy, công thức chung cô có ghi trên này. Đây,
dạ em hiểu rồi cô, cảm ơn cô.
Any other question, please? Các bạn còn câu hỏi gì nữa không? Các bạn không còn câu hỏi gì, các bạn say no. Okay, if you don't have. So let me move on to các bạn ơi, TA đã post cái bài de novo lên Blackboard chưa các bạn? Các bạn có thấy bài đó chưa? Bạn thấy cái bài de novo chưa các bạn? So I send it for you in this way. Everyone, do you want to practice more example with non-preemptive role framing? So everyone, before I move on to de novo, so I think I should send you one more example with non-preemptive role framing. Okay, everyone. So, because in the previous lesson, I just give you one example with non-preemptive, I think it's not enough. So, I will give you one more example, and I want you to practice, summarize, and practice that. I give you a time. Okay, everyone, do it, please. Yeah. I mute because I'm waiting for your summary and formulate it. So everyone, do you summarize this one? I give you the time for practice by yourself. Just let me know if you finish and or any question. Hello, everyone. Can you formulate this one? Bạn ơi, các bạn mà summarize nó chưa các bạn? Okay. Đang làm nhưng mà không chắc lắm. Em cứ làm đi. Em làm xong rồi khi mà cô giải á, thì em mới sẽ hiểu bài. Cô chờ các bạn dạ xong rồi cô giải. Okay, everyone. So let me summarize that one. So Sarah William, they have 100,000 to invest. So Bill, that is her investment counselor, have prepared the following estimate for the potential annual return on each investment. So she have 4 investments here, and they have expected return, have minimum return, and maximum potential return. Okay. So Sarah wished to invest her money. So she wants to maximum her expected annual returns based on the Bill Wallace projection. So they have 4 rejections here: 1,000, 100,000 for invest. She also won 50,000 in stock. Her investment is in stock. At least 60,000 investment should be minimum potential earning at 9% or greater than annual return. And she has set 3 goals. The first, that is the minimum overall annual return should be at least 4. Expect should be at least 10, and almost 30,000 can be invested for 2-year treasury bond. So that at least is 70,000 can be immediately liquidated. Okay, so in here we have 4 variables, right? We have, so I can write the first is B, C, N, and T. So that I represent for 4 investment here, everyone. 4 investment. So her goal, that is the minimum overall annual return, should be at least 4%. of 4% of 100,000. So here we have 150 plus what everyone that they expected, right? 0.09 plus what 0.07 plus what 0.08. And here that is at least is mean greater than 4% times what 100k, right? For the second one, everyone. So, sorry, here expect is 10. Sorry, that is 10. 10%. That is 10%. Sorry. So for medium, that is 0.5. B plus what 0.03. So medium here, everyone, medium, minimum. C plus what 0.06, that is M, plus what 0.08, that it is. So greater than 4% times what 100k. So almost here, that is 2 year treasury poll. 2 year, that it is should be greater than 30. Okay, right? That is goal program, goal objective. Following the goal for each objective. So for goal, we should add V1 plus minus V1 minus V1 plus 2 minus V2 plus. So here should be equal, right? And here plus with D3 minus D3 plus is equal. And right now we move on to the hard constraint. Hard constraint, he said that is 100,000. It's heavy rate, so I will close the door. Everyone, wait a minute. Okay, so I move to the constraint is 100,000 for investment. So it means B plus C plus with N plus with T cannot over 10,000. Okay, and almost 50. In stock, everyone, in stock, two type of investment in stock, that is B and C, right? B plus with C here B and C is in stock. At least is greater than 60K. Maximum potential earning. That is the maximum potential return. 9% or greater than annual return. So here that is greater than 9%. Right? So it means we have B, C, and M. So what is the minima here, everyone? Minima what? Z will be equal. So this paragraph say, Sarah wants to set up a Go programming model where the minimum annual return is considered twice as important as the expected annual return and 3 times as important as the liquidities of her portfolio. So what does it mean? So annual return. What is the annual return? Minimum annual return, that is D2. So at least, right? At least, so we minimize what? At least is minimize D2 minus, right? And for the goal here one, at least 10. So it's minimize D1 minus. And here almost is minimize D3 plus. D3 plus. So right now we must to input the weight here. So she said that minimum is considered twice at the expected annual return and 3 times important. So here that is 3 times. So it means that is 1, so that it will be 3. But that one will be double this one. So it's 1.5, right? Okay. So when you don't have like hard constraint here, B, C, M, T must be non-negative. Di plus Di minus should be greater than 0. Any question for me?
I want to ask you about constraint E plus.
Yeah.
Let's say, is it equal 100? Is it equal 100? Let's say
This one?
Yes.
Yeah, let the denote equal. Let the denote equal. So it means the total money they invest is 100,000. So cannot over that number. The meaning here is cannot over that number. So let the
so I think why?
So you want equal here, right?
Yes.
Yeah, but if you put equal here, it means you must to use all the 100 here. But in case you can get the objective what lower than that number. I think that is the better. Right?
We don't use 100,000 to invest. So the interest at the constraint 1 and 2, at the goal constraint 1 and 2. So we will don't multiply for
Yeah.
100%.
Yeah, but it means that lesser than or equal, you can use equal, allow you use equal. So yeah, allow you use equal. But in case that is lesser than, so it means like here. For example, when you have the feasible region like this, right? The feasible region. So 1,000 here, 1,000K. You can use that this one in this. If not, cannot over. So it's just that meaning. But if you put here equal, so it's hard for you to find a solution because you know that lesser than 1,000. So for example, here lesser than 1,000, you have the area, right? Area. That big area. But if you use equal, so you have just a line. So when you find the solution in the area, so easier than if you use the line here. So please consider when you put equal here, when you solve the real problem.
Yes, okay, thank teacher.
Teacher,
Yes.
I want to ask the second goal.
Second goal, yes.
In the problem, it says minus 50%.
Minus
But
50.
you wrote 0.5 only.
It's my mistake, sorry. It's minus. Thank you. So everyone, any question? I have no question. If you have no question here, so we can take the break. 15-minute break, and after that continue with de novo. Everyone, we just have one more lesson, right? One more lesson and one more week. So I'm trying to finish the final lesson, and for our next class we will practice. Give you more time to practice. Okay, so right now take 15-minute break, everyone.
Teacher.
Yes.
I want to ask about the objective function where the number, the coefficient of 3 and 1.5.
Where that come from?
Yes.
Yes. Yeah, here you see that. Look at this. Shara wants to set up a goal model where the minimum annual return is equal to as important as expected annual return. So here that is twice, right? And here that is 3 times. So 3 times as important as liquidity of her portfolio. That is her portfolio. Okay?
Okay, then I understand. Thank you.
Yeah. Any other questions? Everyone, so take 15-minute break and we will continue. Hello. Hello everyone. Did you come back? So that is everywhere outside. Hello. Các bạn vào chưa các bạn ơi? Okay. Thank you for your response. Okay. So everyone, I'll try to teach you de novo. Is maybe we cannot finish that one, but just try to study it, and we have more time to practice in next class. So we study with global, we study with compromise, Go programming, and today lesson I'm teaching you de novo. So de novo, that is one of the methods to solve for multi-objective. So, but what is the difference between Go and de novo? So I will tell you. Okay. So first of all, let me introduce about the de novo. De novo here that is proposed by Professor Jean Lany. So it's long time ago. You see, it's 1981. It's 1986. So his idea that is optimize the given system and design for optimal system. So everyone, and you can see that for Go, for global, for compromise. So we try to transform multi-objective, right? We try to transform multi-objective here become single objective. Single objective. Single objective that is always minimize Z, right? Try to transform that. And we have the constraint here. So is from the constraint, everyone, from the constraint here, we can draw the feasible region, right? We'll draw one feasible region. And we try to find the solution in feasible region here. So if your objective is outside, the ideal solution outside, so we try to find which one is close with. So for example, here is ideal solution. ideal solution. So it means we try to find the efficient solution that, and select which one is the closest ideal solution. That is, it means maybe we can choose this one. We can choose that is close, right? Closest. But we cannot reach that point. That is always outside. That is what we studied in previous. But today's lesson, I'm going to share you another method. So right now, instead of we select the point close with the ideal solution here, we can redesign the system. It means we can redesign, we can improve the feasible region here. We want to, maybe we can like this. So we include this point into the feasible region. So that will be the feasible, right? That will be the feasible solution, optimal solution. We include that point. So it means that if you have the given system, so the given system is mean we have like this, given this, the blue one. So you want to reach that point. So right now we can expand the feasible region. It means you input more available resource. That is the constraint, right? So we can relax some constraint. So we have like this. That is, you have the given. So, but if you design the new system, if you didn't design new system here, so and at the beginning, so you include that in that point. Okay, everyone, so you can see they have the great idea, right? So I want to share you. Everyone, wait a minute. Yeah, right now I cannot find that file. I want to share with you to read that, but later on. So that is the de novo, everyone. So if you want to reach that point, you should relax some constraint. Okay. How much money you must, or how much research you should input in here to reach that point? So the Go programming can let you know. So for the given system, we have here, right, given system and optimal system. So for given system is single objective, that problem of measurement and search, measure and search. For multiple objective, that is problem of precision making and search. So what is the measurement, problem of measurement, and what is problem of precision making? So for single objective, as here earlier, I will tell you that single objective. So we go to search, and we measure that which one is the best one. right? You search and you can find which one is the best. But for multi-objective, that is the problem of decision making. We also search, right? But we can make the decision. So in here, you can choose the best, maybe close with this ideal, but you can insert with some criteria. Some criteria, for example, here that is the efficient solution, efficient solution, right? But I just have 10,000. My budget is just 10,000. So it means my solution is different what if I have 12,000, right? So also in the efficient, but if you ask some criteria, so you should make the decision on this one. So here that is the problem of decision. And for single, we try to find the optimal. So we just go to search and which one optimal, that is the best one at the optimal solution. So for the optimal system, that is the problem of design and measurement. And for multi-objective function is also the problem of design. Design is mean, so you have the goal here. You want to reach that point, so you can design your system, design here, or you can make design here, design the feasible region, and after that you can make decision. So that is the optimal system. Okay, so let me give you the procedure of programming, the de novo programming. So everyone, we have maximize z equals cx. So see here, I'm right that in the matrix. So we have a x minus b greater than equal to 0, p is greater than p, and here that is x is greater than equal to 0. So x is represent for matrix. A here is matrix, everyone. Matrix. So do you understand the matrix? So for example, here I'm write x1 plus with 2x2 minus 3 greater than 0, 2x1 plus 3x3 minus 4 greater than 0. So the matrix here, matrix A is 1, 2, 1, 3. Okay, that is the matrix. And matrix B is 3, 4. Okay, that is matrix general formula. So P here, that is the unit price for M resource. That is the money you have. Money, the budget. That is the constraint, is annual, and that is like normal constraint, but that is constraint for budget. So that is the unit price. Unit price for corresponding with the resource you have. So I will give you example later. You can figure out this. So from this one, everyone, from the model here, for procedure, de novo programming, that is the step 2. The next step, we can the second step here. The second step is we can find the aspiration level Z for solving each function system cell rate. So Z here is mean Z, we have like Z1, Z2, right? Z3, because that is the multi-objective problem, is it? Multi-objective problem. So we can find the solution for each one. We find the solution. So for Z1, you find optimal solution. So we have Z here, that is the optimal solution. You can find the value optimal solution here, right? Why we just solve the problem? It means we take Z1, compare with the constraint here, we can find the Z1 star. Same with Z2 and Z3. And here we transform that, maximize. Z will be equal with Cx is the same, right? But here, I'll rewrite that is Vx lesser than B and x greater than 0. So here I let B, our V will be equal with PA. I let V equal with PA. So if I have Vx, so here I have PVx, right? Okay. So it here. If I have from the constraint 1, I rewrite the constraint 1. So I have, if I have PVx minus, here I time with P, right? P will be lesser than equal to 0, right? If I time P in this constraint. So I can write that PVx lesser than PV. But PV lesser than P, lesser than equal P. So this one equal Vx is this Vx, so Vx lesser than P here. I can write that. Any question? Clear on this one, everyone? Is it clear? No question. Right? So from here, from the model here, I can write like this. Mean B star, mean B equal Vx, and I have Cx greater than Z star, and x greater than equal to 0. So how can I write from here to here? Is equivalent, everyone. Hello. So how we can transform? So if you look at this one, everyone, any idea? Bạn nào có ý? Bạn nào có giải thích tại sao cái này bằng chuyển qua này được không các bạn? Hello. Có mình các bạn nào học bên toán không các bạn? Hồi đó mình học chuyên toán hay là chuyên toán? Okay. No idea, right? So you have Vx here. Vx is lesser than equal B. It means minimize Vx equal B, right? B will be equal, sorry. Mean is minimize B will be equal Vx, is it? Vx lesser than equal B. So its smallest of B here will be equal Vx. So the same. Maximize Z equals Cx. So maximize Z. Cx will be equal maximize Z. So Cx will be greater than here, right? It means so you can see that Z will be lesser than Cx. Z. So it means that maximize of Z here will be equal Cx. Right? Maximize Z equal to Cx here. Minimize B will be equal with this. Everyone is clear? Các bạn ơi, được không các bạn? Okay. So we have the model like this. So and after that we find the ratio x. The ratio here. The ratio we find that is the P with P star. P star is the minimum the purchase you must to pay compare with original purchase here. So that may be lesser than 1 or maybe greater than 1, right? So maybe it's the same, maybe lesser than, because we must to pay more money if we want to reach that point. So for example, if the original purchase, you get that one, that P, and the point ideal here. So right now we must to pay more money. That's one. This one. Okay. So So that is the total here, that is the B star, and original P is that one, right? So take the ratio. So from that ratio, so you will have the ratio for the right hand side B here. So B here we from that we will B will be ratio time with B star and answer is B star and Z also. You can find that. It means why you need to find that one. Why you need to find B and Z here. It means we will redesign the system. So we expand that one here. So how many, the constraint will be changed, right? Z will be changed. That it will be redesigned system. Okay. So everyone, I give you example. Example here, that is the available resource. That is the unit price. Available resource is mean B, small b, everyone. Small b. Here that is P. Okay. So that is the money. So we take P and B, we time together, so we get the budget money here. So it means we have tied the machine. Here that is the available is like the number of machine, like the number. The parameter is million machine, we need is 1,400. That is the unit price for each one, right? So we time together, we get the money, budgets. That is original P we have. So that is the technical coefficient. Technical coefficient here, that is the A matrix. So you have the matrix. So product one is 12, X1, 18.
Dạ cô ơi, nãy giờ cô có show slide không cô?
Cái slide của nền preemptive.
Nó chỉ là cái Word nãy giờ cô.
Giờ không nói sớm. Bây giờ nói gần một buổi trời rồi, giờ nó không nói. Nãy giờ các bạn coi trong này, các bạn có nhìn slide không hay là nhìn bảng cô không vậy các bạn? Có theo dõi trong slide không? Okay. So example here, everyone. Look at the slide 10, number 10. So that is the P value. That is P. Okay. So it means we have 6 types of machine. So it means available resource is we have the number of million machine, and that is the unit price for 1 million machine. So we time together, we get the budget B here. And so for the second one, the information they give, that is the coefficient of the product one. For product two, it means here the metric A. So for million machine, they need like 12 product A. They have 17 product B and 0 product C, right? So okay, etc. So on. It's the same. So we can write that like 12x1 17 0 greater than B is right hand side, right? Because milling machine, they just not over 1,400. And here that they given you the information, the maximize Z1, Z2, and Z3. That is multi-objective. So right now, everyone, we have the form like this. Sorry. We have the form like this, right? So right now, we transform them, become the model here. Maximize C and trend to mean. But before you do that, you must define the solution here, Z1, Z2, and Z3. So for Z1, we find the optimal solution. It means that everyone is mean you take Z1 here, you compile with subject 2, so you can get the solution is Z1 here. X1, X2, and X3. Z2 and Z3 are the same. So you have the vector Z here, right? Okay, that I will explain later. So right now, we transform. You can see we have Z here. Finish right. Right now, we transform. Here, still Z equal to C, right? C, X. So I keep here the same. So subject 2 here. Subject 2. So you can see Vx is mean Vx equal to Pax, right? Pax. So P 0.7, P here. We take P, right? We time with Ax. So here that is Ax, the matrix Ax is here. Okay, so you have here that P time with Px lesser than B. So lesser than money here. So in this stage, the main purpose of this one is mean we try to transform other constraint become one constraint related with budgets only. You can see that. So here you have the budget. Here you have other constraints like machine, like labor, everything. But we try to transform them related with only budget, only money. So, okay, everything we should work with things that budgets. So, we take Z1 here, we compile with subject 2, we can find a solution. Z2, the same, Z3, the same. So you have the solution here. Okay. So next, that we transform this one become to B star. So B star, that is CV. CX Vx, sorry, Vx here, everyone. Vx is mean from the constraint, right? Here that is the Vx. So we take sum of them, sum all here will be equal with that number. So B equal to Vx. And right now Cx Z greater than Cx. Cx here, that is Cx, right? Cx1, Cx2, Cx3 will be greater than Z star. Z star that you just get from here, right? Z star, Z star, Z star. Yes, from here. So you have that model. Right now, you can see that it's a single model, single objective. Single objective. You just solve that easily. Simplex methods you can solve. And the solution you guess that is a number. Solution you guess is the number. So you substitute the value here in that one. So you can get B1, B2, B3, B4, B5, and B6. Here. And you substitute this one in Z. In Z, that's this one. You get Z1, Z2, and Z3 star. So it means you just find here, right? Right now you take the ratio. So the ratio B divided by B star, you get the money, the original one, and here that is what we need. So the ratio here that is 0.7. It means you need two more money, right? You need more money if you want to reach that point. So you have Z here, and Z star, which is 5. You have R, you get the number here. And B star, which is 5 in the previous slide. So here B star, you have Z star also. You substitute in here, you can find B. And that is P, cost. So after you, everyone, after you rewrite, after you redesign, so you have the right hand side like this, and that is the new one. So I can copy that one with the original one. So you can see here that is 1,400, but here that is more than 2, right? And if you time together here, so you get the money, right? So if you take this one, you time with this one, you get the money here. That is we, and totally here we get that is 6,600. Okay, here that is the 4,600 something. So that is after we redesign. Okay, everyone. Here. After we redesign. So any question? Any questions? So everyone, I give you an example and I want you to practice at home. Okay. Because that is like include going to. So here, because that it include the goal and de novo, so you can see it de novo example. So everyone, when you study with de novo programming, so I want you pay attention when you solve the real problem, even though for commonly or for your life. So it's kind of, if we cannot solve that problem by money, we can solve that problem with more money. Is it? So, everyone, if you want to reach that goal, you pay attention. If you want to reach that goal, you must to relax some constraint. You must to relax. So you cannot reach that point without relax constraints. Remember that. When you so that how you cannot reach that goal, that your goal. So with the constraint, the constraint you have. So you must think, the first thing you must think about, which constraint we should relieve. Okay, think about that. So you can reach that point. So you can apply this in your life. Everyone, make the decision in your life. Any question for me? Hello. Câu hỏi gì nữa không các bạn? Okay. If you have no question, so I end the class. We stop here and see you in next class. Everyone, so for the goal programming assignment, I would like you to solve that and you can upload in the MS Team. I will see it. I want to see that. And I will upload the solution for you to double check. Okay? So I want to see it in the MS Team, everyone.
Cô ơi, cô giải thích lại giúp em cái slide 15 luôn. Dạ.
Có nghĩa là cái machine, cái loại machine thứ nhất ha, loại machine thứ nhất thì nó chỉ có là 1.400 thôi, đúng không? Nó chỉ có 1.400 thôi. Vậy thì bây giờ nè, bây giờ cô nhân 2 vớ đây, cô nhân 2 vớ cho 0.75 đi, tại vì cái unit price của nó là 0.75 mà ha. Cô nhân cho 0.75 bên left hand side và right hand side. Rồi ở đây là unit price nó là 0.6 ha, thì cô nhân 0.6 cho cả hai bên, tương tự 0.35 cho cả hai bên. Này là nhân cho 0.5, cái này nhân cho 1. Rồi cô nhân hết vô thì cô cộng lại thì cô được cái con số này thôi.
Dạ, em hiểu rồi, em cảm ơn cô.
Các bạn về coi bài lại nha các bạn. Cô giảng cái này cũng hơi nhanh á. Nếu mà các bạn có câu hỏi gì thì các bạn coi bài lại và hỏi cô vào hôm sau ha. Okay, everyone? Any other question? You have no questions, so we'll stop here. No, right? Okay, bye-bye. See you in next class. Final class, so I hope everyone attend my class. Okay, see you.